In this video, I'm going to go through standard form, or what we call scientific notation. So I'm going to go through some basic questions to reinforce your understanding of standard form, and then in the subsequent videos, we're going to go through different types of questions you might face, and even application questions regarding standard form. So really quickly, the definition of standard form, it's a way of writing big and small numbers in a standard way, such that you always have a number that's between 1 and 10, and that number is being multiplied by a power of 10. And this power has to be an integer, so it could be a positive power and negative power. So something like 3.2 times 10 to the power of 3, that would be a writing in standard form. You could also have numbers that are very close to 10, but not at 10. So if I do 9.9999, for example, and that times 10 to the power of negative 2, for example, that's still allowed. I'm still between this boundary, and the power of 10 is an integer. So these things you need to keep in mind when doing standard form. Some of the questions in standard form is to write numbers in standard form. So I'm going to go through a couple. You can pause the video, attempt the rest, and then I'm going to put up the solutions. So I'm going to attempt part D. So in this case, this number, you immediately need to remember the form you need to put it in. This number is not between 1 and 10. So I need to change it to make it between 1 and 10. And the only way to do that is to move the decimal point that is here. And I need to move it all the way there to make it a number between 1 and 10. So you end up with 2.56. You don't need to include these zeros. You won't be marked down or given extra marks for writing these zeros. We tend to not write them for mathematical writing. And then I need to multiply this by 10 to the power of, well, how many decimal places did I move it? It's 4 spaces. Now, why is it a positive 4? Well, keep in mind that standard form doesn't change the number. It just changes how the number looks like, but it doesn't change the value of this number. So this arrow is actually an equal sign. So these are exactly equal. If you had to evaluate this, let's do it on the side, 2.56 times 10 to the power of 4 is basically this. If you're expanding it, I'm taking the longer root, which is times 10,000, and times 10,000 means you're going to move this number 4 place values. So you're moving it 4 place values, and you end up with 25,600. So you're back to your original number. If you ever forget if it's a positive or a negative number, do go through this process. That's why standard forms are easy to check, because you can actually go through your answer. Now, what if it's a number that's less than 1? Well, this time we'll have to move the decimal to the right, and you end up with 2.56 times 10. Well, I moved it to the right, so it would be a negative power of 1. And I only moved it 1 space, so it's negative 1. Again, you can check your answer. Say 2.56 times 10 to the power of negative 1. Remember that powers of negative are reciprocal of this number, so 2.56 times 1 over 10 to the power of 1. And basically this is you just dividing by 10. This is over 1 because it's a whole number, so you have 2.56 divided by 10. If you multiply by 1, multiply by 1, normal fraction multiplication. And if you divide by 10, you move the number by how many place values you have. So I'll have to move it by 1 place value to make it a small number, so it's 0.256. So generally you can come up with rules that if you move the decimal place to the right, it's a negative. If you move it to the left, it's a positive. You can also say that if it's a negative power, then your original number is a small number. If it's a positive power, then your original number is a big number. So you can attempt A and B. A would be quite interesting because it's already in standard form, so how do you think you should write the powers? Try to look through laws of indices. You can attempt these. I'm going to go through this example just to show you what happens when you actually have it in, when you have a 10 there already. It's already being multiplied by a power of 10. Now this is not in standard form because the a part is not between 1 and 10. And so you'll have to change it. Now there are two ways to do this. Either you find the original number for this value, and then change it to standard form, or we could use the information we have here and change it. So I'm going to try both ways. So I'm going to say method 1, and I'm going to say, well, I'm going to change it back to the original number. So I'm multiplying by 10,000. I need to move this decimal place 4 spaces, or I'm moving it 9 place values. So that's 1, 2, 3, 4. If I multiply back, I get back to this number. So this is the original number, and then I need to write this in standard form. So I'm actually moving the decimal place all the way here, which is 1, 2, 3, 4, 5, 6 spaces. So 9.371. Again, you don't need to write these zeros, times 10 to the power of 6. Method 2, which is a quicker method, and I would recommend using it as soon as you actually understand the fundamentals of standard form. Well, if you're moving it 2 spaces to the right, that's all you need to do. You're basically 9.371 times 10 to, it was 10 to the power of 4, and now you just moved the 2 decimal places to the right, so you're actually multiplying by 2. Well, you have a multiplication, you have 2 numbers with the same base, and you have powers, which means you can use laws of indices, and you can just add the powers. So it's times 10 to the power of 6, 4 plus 2 to be 6. You don't have to write the step, you can immediately just show the step. It does mean that you understand that you're moving 2 extra spaces, so that's 2 more 10s that you're multiplying. So you could just add these 2 more 10s to the power that you already have. So have a go at the other questions. It would be similar to this, but be careful with the negative power. If you have a -2, for example, and you're adding another negative, so you're subtracting 1, for example, or subtracting 2, so you need to be aware of these methods. I'm going to go through part H just for the sake of completion. So in this case, you want to move it 2 decimal spaces to the right. It's a small number and you want to make it look like a big number. So let's use method 1. And I'll change it to the original number, so I'll have to move it. Remember, it's a negative power, which means this was a much smaller number, which means you're dividing by 100 here, because it's 10 to the power of -2. 0.05 times 10 to the power of -2, 0.05 times 1 over 10 squared, which is over 100. So you are dividing by 100, and so you'll end up with making it a much smaller number. So you have 0.0005. Now you can change this to standard form, and you're moving it to the right 1, 2, 3, 4 spaces, so it should be 5 times 10 to the power of -4. Let's go to method 2, and you have 0.05 times 10 to the power of -2. Well, you want to move it 2 spaces to the right, so you end up with 5. And it has to be, that's the original one. So let me just indicate the move by an arrow, and then in normal world, you are multiplying by a -2 because you moved it to the right by 2. Well, again, you have a multiplication, you have the same base, therefore you add the powers, and -2 plus a -2 is -4. So you have 10 to the power of negative 4, which is the same thing here. Again, always check your answers, multiply it out, see if you actually get back to your original number or you get back to this number. Have a go at the rest of the questions, and then I'm going to show you the answers in a few seconds. Okay, so here are the answers. Some of them we've done. Make sure you check them, and then if you feel more confident, you can move on to the next video about standard form.